Sample number 3. In this example, we're going to look at population proportion. The question is, using the sample, test whether less than a third of the automobiles manufactured by the 5 countries have at least 30 miles per gallon. So we need to first define in this sample what would count as yes or success. So here S is automobile having at least 30 mpg as the gas mileage. Okay. Then P will be the proportion of automobiles with at least 30 mpg as the gas mileage. And P sub 0 is the value for P in the hypothesis. Generally speaking, it is easy to set up the alternative hypothesis, and that is given by less than a third. So less than a third, put the third as 1/3 in a separate cell. So the null is also 1/3, the opposite of the alternative. So it will be greater than or equal to. We can express this as a percentage. So now we need to set up the sample summary. So count mpg, so that is your sample size. The number of S's, meaning how many of these 38 have mpg greater than or equal to 30, and you can use the count if function for that. Count if of mpg. Now specify the criterion within quotation marks. So you start a quotation mark and then say greater than or equal to 30, end quotation mark and close bracket. And this will count from among mpg how many are greater than or equal to 30, 11 of them. Then P bar, the proportion of automobiles that are S, okay, so it will be 11/38. This is going to give us the P bar value. Okay. Now in hypothesis testing, the standard error for P bar, okay, is this formula, which means you have to use the P sub 0 from the hypothesis. So this is square root of P sub 0, use either one of them, times 1 minus P sub 0 divided by sample size n. Okay. For hypothesis test for population proportion, we always use Z, so that will be P bar minus P sub 0 divided by the standard error, which is right there. So is this a one-tail test or a two-tail test? It is a one-tail test, and we want the cumulative probability, and we have to use the normal distribution. So this is, the formula is always 1 minus norm dot S dot dist. We use always the absolute value of the statistic, okay, and cumulative probability. So this gives us the P value. Now we are ready to make a conclusion, and for that we need an alpha value. When it is not given, we assume an alpha of 5%. That's the default value. Now you can say since P value is greater than 5%, we cannot reject. So we say we do not reject H sub O. So what is the interpretation? Again, two parts to the interpretation. So first part is we cannot reject, so we do not have sufficient evidence to conclude the proportion of automobiles with at least 30 mpg for gas mileage is less than a third. Now the second part is for the p-value itself, and that is if we conclude otherwise, then the probability that this conclusion is wrong, and that would be a type 1 error, is 28.3%. So we need to format this, and there you have it.